Good morning. Today we are going to discuss about the sequential circuits. In the sequential circuits, mainly we are going to concentrate on counters. So what is a sequential circuit? It is a combination of combinational network and memory. Okay. So we are going to apply inputs to a combinational network. So we are going to get the output here. Okay, this is the number one. Combinational circuits. But what is the sequential circuit? Part of the output will be given to the memory, and this memory again they are going to connect to that. So this one is an input, this one is an output, and this one is the feedback network. This one is the feedback network. Okay, so what happens here? This is what are the examples for this? The counters, shift registers, these all are the different examples of sequential circuit. Okay, so how we are going to implement this? Okay, so for counters, what happens here? There are many number of flip-flops will be there. We can use any one, but mainly the counters are divided into two types. The counters are divided into two types. So what are they? If they are combinational circuit, what are they? They are synchronous counter, asynchronous counter. So what is a synchronous counter and what is asynchronous counter? Okay, here in synchronous, all the outputs of the flip-flops will be changed at the same time. All the flip-flop outputs will be changing at the same time. But whereas in the asynchronous counters, the part of the LSB flip-flop output will be given as a clock signal for the next MSB. This is the main difference between synchronous and asynchronous counter. This is the difference between synchronous counter and asynchronous counter. So what is the definition of a counter and what are its applications? So the counter is a sequential circuit which will count number of clock pulses arriving at the clock. So again I am repeating this. What is a counter? Number of clock pulses. Okay, what happens here? These all are clock pulses. So what a counter will do? How many clock pulses it is coming at the clock signal? It is going to count it. That one it is called as a counter. Okay. In this, what happens here? There are two types of this: synchronous and asynchronous counter. Okay. Next one. Is there any other definition for counter? Yes. Then what is it? The counter will be used to generate a particular sequence. Okay. So in a counter, the earlier definition, what happens here? Let us assume it is 0. If we increment it, what happens here? It will be 1. After increment it, what happens here? One more bit, 2. If we increment it one more thing, what happens here? 3. After 3, 4. After 4, 5. After 5, 6. After 6, 7. After 7, again it will be coming back to 0. Okay. So what happens here? Here it is generating in a particular sequence, in an incrementing order. Okay. Next one is one more definition is also there. Again, right now I told you what is it? It is used to generate a sequence also. It need not be in an incrementing order or a decrementing order. Randomly. So initial realization 3. After 3, 1. After 4. After 4, 6. After 6, 7. After 7, 2. After 2, 0, 1, 2, 3, next. Like this. This is also a counter. Okay, we can use these are the definitions for a counter. So first we are going to discuss about asynchronous counter. Okay, again with the same thing, what happens here? We can design an up counter or a down counter or up down counter. Or even any combination we can design. Okay, first we are going to design a synchronous counter. So just now I told you what happens here. In a synchronous counter, what happens here? Output of the LSB will be given as a clock signal for the output of the LSB flip-flop output will be given as a clock signal for the next MSB. Right away, we are going to take mod 8 counter. We are going to design a mod 8 counter. So first thing, how many flip-flops required? What is the first thing we need to know? How many flip-flops required? Okay, and one more thing is, what kind of flip-flop is required here and what kind of flip-flop is required here. Okay, so flip-flop required. Okay, these are the two things we need to remember. So mod H. So what is this mod? Mod means modulus. What is mod? Modulus. What is this modulus? Suppose it is just a reminder. Suppose if you take a bunch of numbers, if you divide with 8, what are the possible reminders? The possible reminders will be 0 or 1 or 2, 3, 4, 5, 6, 7. Will 8 will come? No, definitely no. Will remainder will be 10? No, definitely no. So when we divide with 8, what are the possible reminders? From 0 to 7. That's why it is called as an modulus of 8. That's why it is called as an modulus of 8. Okay. So how many flip-flops are required? Okay. Suppose here 2 power n should be greater than or equal to n. 2 power n should be greater than or equal to n. This small n is the number of flip-flops, required, and this capital N is the modulus. Okay, we need to remember this. So now what is the capital N value here? The capital N value should be H. So if you substitute 1, is this condition satisfying? No. 2? No. 3? Yes. 8 is greater than or equal to 8. So how many flip-flops required? 3. How many flip-flops are required? Okay. And which flip-flop? Which flip-flop we are using? What are the different flip-flops available? The different flip-flops available are yes or set, reset, B, delay, JK, next one T. We can use any one. No? But in asynchronous, we have to use either T or JK. In asynchronous, what we need to do? We have to use either JK flip-flop or T flip-flop only. We are not supposed to use SR or T. We are supposed to use either JK flip-flop or T flip-flop. Okay. So next, so what we know? We choose the flip-flop. So which flip-flop? Okay. J. I'm going to use a T flip-flop. These two things completely. Okay. So now we are going to draw the block diagram. Now what we are going to do? We are going to draw the block diagram. Okay. Here, 3 flip-flops. Clock signal, P. Okay, so I have to differentiate the each flip-flop now. So what I am going to take is this one TA, TB, TC. Next one, what we need to take? We have to apply the inputs for this and we have to know what are the outputs. So TA, I am assuming that we can take it as a QA also. Or we can take A also. A1. Complement of flip-flop, what happens here? Complement outputs will be there. A1. B, B1. Finally, C, C1. Okay. In this, what happens here? We have to choose which one is the LSB and which one is the MSB. Okay, which one shall we use? A or C? We can choose any one. Based on that, we can give the remaining condition. So, I am going to choose this one as an LSB, this one as an MSB. Okay, LSB and MSB. And what is the next step is, we have to connect all the inputs of the flip-flop should be connected to 1 or all the input should be tied to 1. All the input should be tied to 1. inputs should be tied to 1. Okay. Next one, clock signal. What is the next one? Clock signal. Okay. How this clock signal should be there? Okay. There are two kinds of clock signals will be there now, positive edge and negative edge. Here for asynchronous, what we need to do, we have to use only a negative edge trigger. We have to use only a negative edge trigger. We have to use it. What is bubble indicate? Bubble indicates a NOT gate. So previously, without this bubble, what happens here? It is a positive. But we are using a bubble here. So what happens here? It is a negative edge. And for the LSB, what we are going to do? We are going to apply the clock signal. LSB, what happens here? We are going to apply the clock signal. Okay. Next one. For this, what happens here? Shall I come the same clock? No, definitely no. Why? It is asynchronous. Why it is? It is asynchronous. In asynchronous, what happens here? It is going to, each flip-flop will change at a different time. Each flip-flop it is going to change at a different time. So we are not going to connect the same clock signal. So what we are going to be able to do is okay. So what is this one? This one is a block diagram for mod 8 asynchronous up counter. Mod 8 asynchronous up counter. So randomly issue one step. Okay. 1, 1, 0. Okay. So if you or something like this, 1, 1, 0, 1. Okay. So this one is LSB and this one is MSB. And now what happens here? We are applying the clock signal. We are applying the clock signal. So what is the output here? This value is 1. This value is 0. And MSB value is 1. MSB value is 1. Now what happens here? We are going to apply the clock signal. We are going to apply the clock signal. So we are going to apply the clock signal. We know that T flip-flop. T flip-flop, if the value is 1, what happens here? It is going to complement the previous value. Okay. For reference, I am writing the two table for T flip-flop. T. So 0 and 1. So what happens here? If it is 0, previous output. If it is 1, what happens here? It is going to complement the previous output. Okay. So now what happens here? T value is 1. So what it is going to do? It is going to do the complement of previous output. So what happens here? It is 1. Now it is going to 0. Now it is going to 0. 1 is going down to 0. So positive edge or negative edge? Negative edge. So due to negative edge, what happens here with the second flip-flop? It will be on or off? Very good. It will be on. So if it is on, what happens here? What is the value for this TB? 1. So what happens here? It will toggle the previous output. So what is the previous output? 0. 0 will be going to 1. 0 will be going to 1. So 0 is going to 1. If it is a positive edge or a negative edge? Positive edge. But it will trigger only for what happens here? Negative edge. But here it is having a positive edge. So that what happens here? It won't work. So that what happens here? It will be the previous output only. So that now what happens here? The MSB value is 1. Next MSB is 1. Next finally LSB value is 0. So now what happens here? 5 we are having. If you apply the clock signal, what is it? 1106. So like this it is going. Suppose what is this one? Mod 8 up counter. So what happens to the down counter? The same thing, nothing we are not supposed to say much. So what we are going to do here is, instead of A, what we are going to connect is A bar. Instead of A, what we are going to do? A bar. Instead of B, what happens here? We are connecting B bar. But still, what happens here? We are going to measure the output edge. Still, we are going to measure the output at ABC only. Okay. Okay. But what happens is A bar will be connected to the clock signal. Okay. So randomly choose some value. Okay. 1, 0, 0. So MSB value is 1, 0, 0. Okay. Now we are going to apply the clock signal. Now what we are going to do? We are going to apply the clock signal. So clock signal means what happens here? TA value is equal to 1. So that what happens here? it is going to on, so it is going to complement the. So A value is from changing from 0 to 1. Parallelly, what happens to the value of A bar? Previously it is 1, now it is going to 0. So now what happens here? It will be in on state, it will be in second flip-flop will be in on state. And what is the value of TB? It is going to complement the previous value. So what happens here? So if B value is changing from 0 to 1, so simultaneously B bar value will be changing from 1 to 0. Again it is having a negative edge. So that what happens here, MSB value will be, flip-flop will be also in on state. So that what happens here, it is going to complement the previous value. It is going to toggle the previous value. I am not going to write the value of C, but it is not at all necessary, no. So what happens here, we apply 1, 0, 0, and what is the output? 0, 1, 1. 4 is turning to 3. Down, counter. Okay. Next one, we are going to discuss about the up counter. What we are going to discuss? We are going to discuss up counter and down counter. Now we are going to discuss about synchronous counter. What we are going to do? We are going to discuss about the synchronous counter. Okay. So before going to that, brief review. What are things we need to remember in a synchronous circuit? All the input should be tied to 1. LSB flip-flop output should be connected to the clock signal of the next flip-flop, and we have to use the negative edge trigger. So for synchronous, what are things we need? Flip-flop, which flip-flop? Next one, number of flip-flops. Number of flip-flops. Okay. Next one. While we have to for this, we have to draw the truth table. Okay. So for that, what happens here? If you are having a straight diagram, it will be easier for us. Okay. Okay. So mod H means already we just now we discussed now. So what happens is 0 will be going to 1, 1 will be going to 2, 2 will be going to 3, 3 will be going to 4, 4 will be going to 5, 5 will be going to 6, 6 will be going to 7, 7 will be going back to 6, 7 will be going back to 0. Okay. After state diagram, what happens here? What is the next step? State table. Okay. Before that, what happens here? We are going to choose the first flip-flop. Which flip-flop we are going to choose? So we can choose any flip-flop. Okay. So I am going to use a toggle flip-flop. I am going to choose the toggle flip-flop. Okay. So for the flip-flop, what happens here? We have to write the excitation table. What happens here? We have to write the excitation table. So I am going to write the excitation table of Okay, so what will be the value of t? 0, 1, 1, 0. Now, we choose the flip-flop. Next one, number of flip-flops. Just now we discussed now. What is the equation? 2 power n should be greater than or equal to n. Here capital N value is 8. So small n value, if you change the option from 1 to 2, it won't satisfy. So value is equal to 3 flip-flops. Okay, state diagram. Now we are going to draw the state table. So first, I am taking 3 flip-flops now. Just now we got 3 now. So A, B, C. Here C is the LSB, A is the MSB. C is the LSB, A is the MSB. Okay. Or we can take it in the reverse order also. C, B, A. In that case, what happens? A will be the LSB, C will be the MSB. Next one. C A plus, B plus, C plus. Now first, to say like what I can say, we have to write all the possible. So, go back to the, what is the present state? 000. 000. So, what is the next state? For 000, what is the next state? 1. So, what happens here? 0, 0, 1. For 1, what is the next state? 2. For 2, 3. For 3, 4. For 4, 5. For 5, 6. For 6, 7. For 7, what is the next state? 0. So next one we need to which flip flop we choose? T flip flop. So TA, TB, TC. So how to write this? Q plus value T. So A plus, what is the value? 0, 0. So 0, 0, what is the value? 0. 0, 0, 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, 1, 1, 0, 1, 1, 0, 1, 0, 1, 0, 1. Next one. B plus value. 0, 0, 0, 0, 1, 1, 1, 1, 0, 1, 0, 1, 0, 0, 0, 0, 1, 1, 1, 1, 0, 1, 0, 0. So next TC. 0, 1, 1, 1, 0, 1. Okay, like this way. Now what we need to do, we have to plot the KMF for TA, TB and TC. We have to plot the KMF for TA, TB and TC. So 3 variable KMF. So starting from A. What happens here? TA value will be BC. This is for PA. Similarly for PB. So the TB value will be, this one A value will be cancelled, 0 and 1, B value will be cancelled. Next. Now we have to plot for TC. C, E, B, C, 1. What happens here? All form the one group. So the TC value will be 1. So what happens here? It is both lines. What happens here? 0 and will be cancelled. So for B, what happens here? 2 zeros and 2 ones, it will be cancelled. For C also 2 zeros, 2 ones will be cancelled. Okay. So now what happens here? We got the equations. I'm writing here. TA value is equal to PC. TB value will be equal to C. TC value will be equal to 1. Now, 3 flip-flops. Now what happens here? TA value will be AND gate output of B and C. So I'm going to take a AND gate. That AND gate output will be connected to A. But what are the two inputs? B and C. TB value with this, if already this one is here. Next one, TC value is equal to 1. Is it completed? No. Why? It is a synchronous. So synchronous means what happens here? All the flip-flops should be having the same clock signal. Is it a positive edge or a negative edge? We can choose. All the flip-flops as a positive edge or all the flip-flops are negative edge. So no issues with that. So I'm going to take all the flip-flops on positive edge. This is the mod 8 up counter. Okay. Like this, what happens here? We can draw in 4 steps will be there. For all the writing or all the 4 steps, we can design any one flip-flop.